Hello guys, welcome to Statistics Bio 7. I'm Dr. Mohanathanari. The channel fully focused on the biostatistics related video post on the channel. If you like the channel video, click the subscription button and support to me, join to our channel membership. Let's go to the video. Now we are the discussion topic, interpretation of linear mixed effect model in R. How to analyze the linear mixed effect model in R. That video already published in our channel. That video link mentioned to this video description box. If you not watch that video, please visit that video, then watch the interpretation of linear mixed effect model video. Let's go to the video section. The linear mixed effect model is a powerful statistical tool commonly used to analyze data with both fixed and random effect. In ecological and agricultural research, LMM have become a popular method for analyzing experimental data, where measurements are often taken across multiple plots, treatment, or time points. In such case, standard linear model may fail to capture the ingredient variability between the group, leading to beside estimate and incorrect inference. By incorporating random effect, LMM provide a more flexible approach, allowing the research to account for within the group correlation and improve the accuracy of the model predictions. The study apply a linear mixed effect model in R to evaluate the effect of different treatment on plant height while accounting for potential variability between experimental plots. The analysis aim to provide robust insight into the influence of treatment on plant growth with implications for optimizing agricultural practice. So the result of the linear effect model. So the linear mixed effect model was used to analyzing the effect of different treatment on plant height while accounting for the random variations across the different plants. Below, the interpretation of the model result in linear mixed effect model. So this is for the effect model table in LMM. This is for the fixed effect, the treatment BCDA and intercept, the estimate value and standard error value, the difference of freedom value, T value and P value. So the result for the fixed effect table, the fixed effect indicate the intercept and the treatment type BCD. The intercept represent the estimate averaging the height of plant receiving the treatment A, which in the height 15.5 centimeter. So the effect of treatment B is significantly lower than treatment A, with an estimated decrease in plant height of minus 2.875. The p value 2.39 e to the power minus 5, the indicating the treatment B result is shorter plant compared to the treatment A. So the treatment C lead to an essential increase in the plant height by 1.03 centimeter compared to the treatment A. The p value is equal to 0.03046. Suggesting that it has a positive effect on the plant growth. The treatment C. The treatment D has a significant negative effect, decreasing the plant height for minus 1.38 centimeter compared to the treatment A. The p value 0.00672. So the next one table for the linear mixed effect model in random effect. The intercaps and residual, the group and variation and standard deviation value. So the random effect of the plot has a standard deviation of value 0.0787 centimeter, indicating the minimal variation in plant height across the different plot. The residual standard deviation is 0.840 centimeter, showing the variability in plant height that is not explained by either the treatment or plot. So the next one interpretation for the linear mixed effect model graph. So the x-axis for the treatment type and y-axis for the plant height, and the factor for the plot 1 and plot 2. The red color is a black plot 1 and the blue color is a plot 2. So the linear mixed effect model was used to investigate the effect of 4 treatment A, B, C, D on plant height, accounting for variability between the experimental plot. The model indicated the treatment type as a fixed effect and the plot as a random effect. The analyzing revealed a significant effect of treatment on plant height. The treatment C produced the tallest plant across the both plant, with an average height of the 16.8 centimeter in plot 2 for treatment C and 16.4 centimeter in plot 1 for treatment C, indicating it is superiority in promoting the growth, the p-value less than 0.05. Conversely, the treatment B result in the shortest plant within the height of 11.9 centimeter in plot 2 and 12.9 centimeter in plant 1. The treatment A and B showed the intermediate height with most difference between the plots. The random effect of the plot was significant, suggesting that the variability between the two experimental plots contributed to the difference in the plant height. However, the overall pattern of the treatment effectiveness was concerned across the two plots. So the conclusion section of the linear mixed effect model in R. The linear mixed effect model indicates that the treatment type has a substantial effect on plant height, with treatment C being the most effective at engaging the growth, while some plant specific variability was observed. The general trend in the treatment performance were concerned. Those findings suggest that treatment C may be the most beneficial for the promoting plant growth under the experimental conditions. So this is for the interpretation of the linear mixed effect model in RStudio. If you like this video, subscribe to our channel, and any doubt on this sections, post comment in the comment box. I will help you. And if you like to sponsor this channel, please join to our channel membership. Thank you.